Hello, my name is Chase Knutson, and this is Lab 4, the Spring Mass System. What we'll be going over is the introduction, fundamental physics principle, procedure, tracker analysis, potential errors, and what-if questions. Introduction. What was the lab? This lab examined the motion of a spring mass system moving in two dimensions, where the mass both oscillating vertically and swings in an arc. The motion was recorded using either a provided video or physical experiment, and tracker was used to extract position data in the X and Y position. For my case, I decided to do the recorded video. The collected position data was then used to build a computational model in GlowScript that simulates the motion of the system using physics laws. The model allowed comparison between the observed motion and the predicted motion. The purpose of the lab. The main purpose of this lab was to determine whether a computational model based on physical principles could accurately predict the motion of a spring mass system in two dimensions. Additionally, the lab aimed to analyze how energy changed throughout the motion, comparing kinetic energy, gravitational potential energy, and spring potential energy, and to determine whether the total energy of the system is conserved. Fundamental physics principles used in Lab 4. The spring constant, F equals negative kx, which is Hooke's law. The spring exerted a restoring force proportional to how much is stretched or compressed from its relaxed length. Newton's second law, F equals ma. The energy principles. The total energy of the system is the sum of the kinetic energy, gravitational potential energy, and spring potential energy. Procedure for Lab 4. We had to set up the tracker, calibrate the video using a known length, align axis appropriately, track the mass frame by frame, extract data, record X and Y position data only, export data into a .csv file with no headers, build model, input the data into GlowScript, calculate forces using gravity and spring force, update motion using Newton's second law. And then we had to analyze the result. Compare predicted motion to tracker data. Plot energy changes over time. Estimate oscillating periods from X and Y motion. Tracker output. We had to set the scale, use a known length in the video to calibrate distance. We had to align axes, place the origin and align axes with motion of the system, and track motion. Track the position of the mass frame by frame in both X and Y. And then we had to interpret the data. Use position data to calculate velocity and analyze oscillatory motion in both directions. Here's the tracker output that I got. Here's the code that I got. Here's the photo or the visual of it. Potential errors. Calibration errors in tracker. Small inaccuracies in tracker position frame by frame. Incorrect estimation of spring constant or relaxed length. Numerical errors from time step size in the simulation, and energy drift due to approximation in the computational model. What if? What does it mean? Energy principles. The total energy should remain nearly constant, and small changes in the graph indicate minor numerical or measured errors. Oscillation periods. The periods from X and Y motion may differ slightly because the two dimension is influenced by both swinging and stretching of the spring. Thank you.